challenge, but I think we need to go ahead and get started. Observe, please, the note well sign. If you utter your deepest, darkest secrets, they will be chiseled into an RFC in stone, and they're out there everywhere, so no well. The agenda that we have for today, at least as it stands, we want to talk about the design choices and the Path MTU document today. And then we have some presentations from actually 4 networks that are deploying MAP-T and MAP-E as defined by software. And going to have them talk a bit about their experience with that. Then tomorrow, we will have Tori Anderson presenting from Norway, and have Fernando Gaunt looking at extension header problems that he's been observing. And then 3, I think, shorter talks, one about a loopback prefix, and Eric Bink and Bing Liu want to understand what the direction, what the working group might want to do with multi-prefix network stuff. So, agenda bashing question. Anybody want to bash the agenda? Do we need to move things around, add things, drop things? Seeing no thundering herd running to the mic. Okay, that's our agenda. You don't need to see Cisco's internal mail, do you? Okay. So I thought I would start out today with a little bit of what I'd like, what Lee and I would really like to see happen in this session today and tomorrow, the meeting that we're looking at here. We have 3 documents that we've discussed before, and I suspect are approaching a state where we can send them to the ISG. The CIDR prefix one, we've actually already pretty much decided that, but Lee and I overlooked a procedural step, which is that we haven't run a working group last call. So, oops, I'm sorry, we'll run a working group last call. And then the design choices document and the Path MTU document, I suspect we're at a point where we can actually do that. If not, in both cases, we'd like to know what the working group would like to do next. And then tomorrow, Tori Anderson's documents, he would like to see one of them adopted by the working group that has not been adopted. And then he's looking at a possible update to RFC 6145, and which is translation between IPv4 and IPv6, and kind of trying to figure out a roadmap for these documents and how that would work. So we'll want to have that discussion tomorrow, and frankly, the documents are in reasonably good shape technically. We want to make sure that we have the operational guidance in them that would make sense. And we want to figure out what that roadmap looks like for those documents. So that'll be a big part of the discussion tomorrow. And then this is more of a question, and I suspect we'll probably actually take time to discuss it tomorrow. We'll have more time, but this will be building on the presentations that we'll see today regarding MAP-T and MAP-E, and building on Tori Anderson's documents. What those are all looking at, and what 464 XLAT in essence is IPv4 as a service. That can mean translation directly into IPv6, so that IPv4 is somewhere else. It can mean, in one way or another, bringing an IPv4 address up to a device. So for example, if I've got a a web application that I'm running in a data center, for the most part, I can translate somewhere else and bring it up as IPv6 into the data center application. But if I'm running Hadoop, which is a data center application, at least at this point, it's IPv4 only. If that's not a great example, I know there are other great examples. And so, we find ourselves actually needing to bring a v4 address in. And that's a problem because we've got data centers that, we now know of a data center in Iowa that's in the process of being built that has enough space for 500,000 racks. So now how many bits of equipment can you put in a rack? How many VMs can you put in a chassis? Do the math. That's going to need to be a V6 data center, or it's going to multiplex like addresses like there's no tomorrow. But we know that it will need V4 as a service. So as we're developing these technologies, as we're starting to deploy them in mobile networks, in data center networks, in service provider networks such as we'll be discussing this morning, we, the IETF, and probably hand in hand with the network operator groups, are going to need to do something about what kind of guidance do we give people? How do people go about building IPv4 as a service? Now, question that Lee and I and the Sunset 4 chairs and Joel have been discussing overnight in email is, so what working group does that belong in? And what impact does that have on really the charters of the two working groups? But so is that going to be something we discuss in Sunset 4? Is that something we discuss here? The IETF, and I think hand in hand with the operators, needs to figure out what advice, what guidance it would give. So this is a conversation I think we'll have some of. Joel, are you standing up to talk to the mic? Let's hear. Do we have AV support?
Try again. There's a couple of drafts that have been hanging around in Softwire for a while on the topic of map deployment and lightweight 406 deployments. A couple of years old now. I think they've actually expired. Are you considering those as well, or is that where the work's starting from?
I hadn't actually looked at them, but if they belong in the discussion, then they should be.
Yeah, I mean, I think that the work was done a while ago, but I think it's a little bit out of date now, and probably needs to be brought up to date with real-world implementation experience. But there is something there to build on.
Okay. Hey, boss.
Hey. Joel Yegley. So I think there's a number of possible topics that fit under this rubric, and some of them seem pretty clearly aligned with V6OPS interests. I think some of them potentially have to be hashed out with the internet ADs in terms of potential rechartering that could cover them. I don't think there's anything that's particularly challenging there. I think it's mostly a question of questing for the right place to do them and where the critical mass is. And so I think at least initially we should be open to the possibility that we should be looking at what's the right work and not so much where to do it, because we can go sort that out later.
Well, you notice I didn't put where to do it on the slide. Yeah. So, okay. So at any rate, just heads up. Coming to a working group near you, I think this is a topic that we need to come to grips with. Now with that, let me make a comment now to the everyone who speaks up here. We have a big pink sign here that says, please inform the speaker to stay within the pink box on the floor. Now, if I were writing the sign, I would have said tell or ask. You are duly informed to stand within the pink box, but which is pink, and it's kind of box shaped. But okay. So with that.
Okay. Can everybody hear me? So I'm Philip Matthews, and I've been working on this document together with Victor, who is unfortunately not here, but he's trying to follow this remotely. He told me actually the mics were live so you could hear things. Is anybody actually on Jabber? Do we have somebody on Jabber? Great, okay. He's also going to try the mic button at some point during comment period, so we'll see if you could actually hear him. That will be, I don't actually see anybody over there at the Meet Echo support, so we'll see, I guess, if that works or not. Anyway, so last time you had Victor here presenting. This time Victor couldn't make, because I couldn't make it last time. This time Victor couldn't make it, so I'm presenting. So we're tag teaming on this. So now if I can figure out. Okay, so this draft has been around for a while. Maybe even some of you have read this. So I'm just going to have 2 slides here, sort of a quick recap of what it is, and then I'll talk about the changes that we've done on the draft since Honolulu. So this is now focused down to some routing-related design choices when designing dual stack and IPv6 only networks. Okay, and so for each design choice, we present, here are the options that you can do, here are the pros and cons behind those options. That's the idea behind this. Okay. So just to give you an idea for anybody who hasn't read it, sort of what the coverage, what the choices are that we cover in the draft, here is the list of questions that we consider, and as I said, the options there. Okay, so Victor was up here or in Honolulu and presented this draft, and then we received a number of comments at that time and since then on the mailing list. So he presented 03. We're now at 06, so we basically made 2 big changes and a whole bunch of little changes. The big feedback we got was originally it was this design choices draft, but it never actually covered the entire range design choices. It was pretty much routing related design choices. So we have explicitly narrowed the scope of the draft now. The abstract, introduction, everything else clearly states this is the scope. So that was one. We were also missing a security consideration section, so we've added a security consideration section. Nothing brilliant in that's there. Basically, we went through, looked at the questions, looked at the protocols involved in the design choices we listed, and gave pointers to security consideration sections in relevant RFC. We didn't put anything new in this. And finally, the third thing we've done is we've sort of gone through the entire draft and made some grammatical changes, clean up everything else there, try to make the flow over. There was actually a fair amount of change in there, but again, nothing dramatic. So there's one other point which came up with a huge amount of controversy on the mailing list, so I'm going to hold on that point for a moment, and I just wanted to see, pause right here to see if anybody had any comments on anything else in the draft before I get to this point, which caused about 70 emails to the mailing list.
So let me pose the question in a slightly different way. How many have read the current version of the draft? So a number of us have read the current version of the draft. Okay, back to your question. Comments other than the unnumbered question? Looks to me like.
Okay, good. Okay, so I guess we're there. Okay, so now the question that sparked a huge discussion on the mailing list is what in the draft we use this term unnumbered for interfaces that had only link local addresses. And Mark Smith objected. He said, we shouldn't use that term. It means something else for IPv4. We should use a different term. he would like to use, some term, interface with link local only address, and then it sort of evolved around and he came there. I'll show you the options in a second, okay? So we have about 70 emails on the mailing list as to what we should call these, okay? I have listed all those up there. So number one is what we put in the draft. So we called unnumbered in our draft means an interface that has only link local addresses. As I said, Mark Smith objected to this. He's proposed term number 2, which is link local only interface. Victor, my co-author, a few days ago, proposed number 3, which is administratively unnumbered interface. Okay. Number 4, 5, and 6 were also proposed on the mailing list as possible terms for this. So what I'd like to do now is sort of open up the comments. What term would we like to use for this? Okay, the authors still feel that number 3 is the appropriate term. One of the reasons we like number 3 is it's obvious what the inverse is. We have administratively unnumbered interfaces and we have administratively numbered interfaces. Okay, it's obvious what the two terms are. Marx prefers number 2, okay, link local only interfaces. It's not clear to me what the converse of that would be, but maybe somebody has some suggestions. And then there's the other ones. So, go ahead.
Michael Abrahamson. So for me, unnumbered is something else. So, and I don't know if this is because I'm not a native English speaker, but I don't number an interface, I put an address on it. So I would be fine with anything else that is not unnumbered. And I know unaddressed is not something that works either, right? Because that would work a lot better. But I really, really dislike unnumbered in any kind of form. It just means something, I don't know, I just get in my head when I see that.
Are there any of these options that you prefer, or do you have another proposal?
I publicly said I prefer 2.
2, okay. Do you have a suggestion, just while I'm there, do you have a suggestion what the converse of that would be?
What does converse mean?
So, ones which are not, link local only, one you've assigned an address to. What do we use for that term?
We do not use a numbered interface anyway. You can an interface with address or something like that. I don't know. I just numbered for me is just.
Okay. Well, I think the converse would be around the word only. So it would be a globally numbered address,
yeah.
Or it would be one that does not only have a link local.
Right. That's what we want. The idea of an interface that has some other address other than the link local address.
So my problem here is that the address doesn't have a number, it has an address. And when someone is calling about an interface being numbered, it just doesn't make any sense to me. So
It is a well-used, commonly used term in IPv4.
Okay, okay. I had never seen that before. It's an interface being numbered. So yeah, okay. I don't know. It just doesn't work.
Fred Templin from Boeing. I've been working on an interface spec for really a number of years now, and I've been calling it link local only interface. So that registers with me, whereas the other ones don't so much.
Okay. Again, I'm still looking for proposals for what an interface that is not link local only. What do we call an interface that's not link local only? No, an interface that has some address in addition to link local only.
Something like a routable or global address. But anyway, Eric Vane, Cisco, and as a co-author of the 7404, which is link local only routing protocol, obviously I prefer number 2. And even if my employer invented the unnumbered interface, I find it's confusing, specifically in V6. So use any one of those, preferably 2, but not 1.
Okay.
Actually, Eric, it wasn't your employer, it came out of the OSPF spec.
Really?
Well, I seem to remember, I guess, IGRP having unnumbered interfaces, which it really didn't have an IP address. I mean, you really do have an IP address with a link local. There's an address there, so it is numbered. I mean, it just seems wrong to call it unnumbered. So I like number 2.
Totally ugly. Not an AD in this case. The opposite of link local only interface is basically every interface we have on the internet, which is an interface. So I think that pretty much covers it.
I'm starting to hear some convergence here, so if anybody wants to speak against number 2, please get to the mic.
I'm just channeling Victor. Definition of unnumbered is not marked with or assigned a number.
Yeah, Angelico, yeah, I think when I heard unnumbered, I think something about like dial-up or something like that when the interface doesn't have an IP address. We do have an IP address in this case. It could be used for communication, but just on a link. So I would say like link local numbered interface, or something like number 2 sounds good, yeah. And if you want to refer to anything else, just say it's interface with address of global scope.
David Lamputter. I'm also speaking out for option number 2, mostly because unnumbered in some cases is implemented by inheriting a global address from some other interface, and I really don't want to inherit that concept. So unnumbered is a badly loaded term.
Alex Petrescu speaking with some Linux implementation experience. All interfaces are numbered. There is a number for each one of the interfaces. So it's a data structure number, but it is a number. Interface number 1, interface number 2, interface number 3, and so on. So, for 2, I like the concept of link local only interface, except I think, although I'm not a native speaker here, I think there is an issue with 2 dashes in link local only. In English, I think, but maybe the RFC editor will say something about that.
Yes, actually, I suppose that's true. Mark had proposed without a dash, out the second dash. I just added this because it worked well if you added this as sort of an adjective in front of an interface or a link.
Lorenzo Colidi, I came in late. Why are we talking about this?
Because there was
comment number 1. Comment number 2, I proposed the term sheepskin. And comment number 3, I feel that it is reductive to conduct this discussion limited to terms only in English, because it is not inclusive, and before concluding a term, we should consider which ones translate more easily into all the languages that we support. Thank you.
Well, okay, so the languages we support are English and English? Okay. Okay, anybody else have a thought? Okay. I detect a certain level of convergence.
Okay. So Victor and I have talked about actually we'll spin the draft and do this, but I'd also just generate a short little draft just documenting this, because I think it would be good to have this as a term. If the working group likes that as the term for this, then maybe it'd be good to have a little draft that just says, this is the term we're going to use for that.
Okay. Okay. So now question, do you have any more? You're out of slides. Yeah, okay. So question for the assembled masses. Now that we have this terribly important terminology question out of the way, what do you feel about the draft? Are we ready to take this to working group last call and dump it in Joel's inbox? If yes, hum. Crickets. Yeah. So if no, please hum. Are there other issues that you'd like to see discussed? I hear even less. So.
I suspect we're suffering from the fact that this room is a big room, so I'd like to do that one again and ask you to hum louder. If we're ready to take this to working group last call, please hum louder. If no, please hum louder.
Okay, thank you. So that's what we'll do. I'll do the CIDR prefix draft first, but we'll see that happening pretty soon.
Just one comment. We'll make one rev on this there, and then we'll be ready.
Okay. So, Joel, are you on the path MTU grant? And you are informed to stand within the box.
Yeah, so this should be real quick, and I think slides are basically barely necessary. And so what's new with it? Since the last time we discussed it, which was 2 meetings ago, it's become a working group document. We did a large editorial scrape, so I think maybe every paragraph, but not every sentence in it, has had minor adjustments since the last revision. There was some useful commentary in the last 2 cycles, which I hope has mostly been incorporated. It may not all be there yet. So there are other problems that we still have. I mean, I think places where we could actually improve this. There are other implementation variations that do this. Basically, this is like looking for planets in the rest of the galaxy. The more I look, the more I see people have tried to work around this issue, because basically everyone who does it finds this problem. So one of those was seen in the wild at Cloudflare in their V6 deployment. They wrote a helpful blog post on it, and I asked those folks if they wanted to contribute text, and got some positive feedback from that. So there's at least one more revision required to get that. If there are other people who have contributions they'd like to make with that, that would be useful, because I think one of the things that comes up in sort of the solution space for this is that everybody who does it has a slightly different environment and different set of equipment and engineering constraints. So for example, I didn't have a common L2 when I did it the first time, and as a result of that, I couldn't use IP tables, for example, to replicate packets. I had to do it on an agent, because I needed to spew it across a whole bunch of subnets. I guess the other problem is it's a mitigation. We have talked about this in 6-man in the past, but any work beyond a mitigation is probably elsewhere. And there are other causes of hashing failure, some of which are not specific to IPv6, but which do appear in some of these environments, and so that may actually produce work either in this document, although I don't think we've found anything that we really want to hang on there, or elsewhere. So that's it.
So mic is open for discussion.
Hooray.
Seeing that everybody has something to discuss here. So let me ask the same question. When we adopted this as a working group item, it was seen as, or the sense I got at any rate, was that it was a kind of a no-brainer. Let's make this happen kind of thing. Do you feel that, well, Joel, question for you. You've got some people that said they wanted to add text.
Yeah, so I think there's probably one, if you said, let's take this to working group last call, I would say there's at least one more revision before that happens. So I might not ask for that here, although if you want to, be my guest. But I believe there will be one more version in the fairly near term.
Okay, so after that happens, question for the group, do we feel that it's probably ready for a last call and ship it off? If yes, hum loudly. If no?
Thank you.
So, okay, cool. Thank you. Sorry? Yeah. PC is good. We like PC. Okay, Supreet. So I took a little liberty in inviting some talks. Suprita is here as, so this will change your slides for you. Suprita is here as an ISOC fellow and is involved in a deployment across India. And this deployment being in Asia Pacific, that means they ran off to APNIC and said, okay, we're going to address 1 billion people. Would you please give us a large number of IPv4 addresses? And APNIC said, sure, here's 1,024. And so they're dealing with a problem that basically any new network is dealing with in APNIC, and pretty soon we'll be dealing with in any place in the world. So I asked Suprita, first off, most of us are from not developing countries, and I thought it would be useful to get what happens in a developing country, what happens in that part of the world. And then they're looking specifically at the question of IPv4 as a service, and I thought that she could add to the conversation there. So welcome, Suprita.
Hi everyone, thanks Fred for the introduction. So this would be my agenda, a short one. So to start with, looking at the status of IPv6 in India, Government of India, the Department of Telecom did release a policy guideline in 2013, giving soft deadlines to different sectors or enterprises in India and different kind of providers. If you look at the...
Sorry, maybe a few more centimeters closer to the microphone?
Sorry. Is it better now?
Thank you very much.
Yeah. Thanks. So just to repeat in short, I was saying Government of India and Department of Telecom did take an initiative and released a policy guideline back in 2013, giving soft deadlines to different sectors in India. And it released a status report last year, December, which I'll go through in the next slide. The Ultimate State of the Internet report says we stand at rank 48 with just 0.1% of IPv6 connectivity. Even the BGP table does not look so good if we look at V6's point of view. You have the data there at the slide. And so this is one of the summary which was released in December 2014. So if we look at the enterprise readiness, most of the service providers says they are ready to give transport on V6 to any enterprise, but then they do say that they are not yet ready to give the end-to-end wireless and wireline services to end users. The main challenges there is that the end devices support for the services, like with respect to broadband services, the CP readiness for the V6 only service, and for the LTE services, the smartphones and all that. So looking at that, all handsets launched in India after 30 June 2014 are IPv6 ready, but then the other issue which we see is that content as such itself is not only on V6. So even if the network is ready with V6, we're not able to provide, we still have to have V4 as a service in the network.
So let me ask a question, Suprita.
Yeah.
Back up one slide. When you say that enterprise is IPv6 ready,
yeah.
What does that mean? Does that mean that the equipment in use or the PCs or whatever are V6 capable? Does that talk about the routing system? What do you mean by
It's
V6
just a
ready?
transport network. The backbone is ready. It's dual stack,
Okay.
not towards the edge. This slide shows the front-end readiness in India, and as expected, we do not see much front-end on V6 yet. There are only 80 websites on V6. Even the .in domain is not yet ready for V6. There are front-end like bands and government services, which service provider does not have much control over, are also on V4. They are slowly transitioning towards it, being enforced by the Government of India. So we do see that there are issues with end device support and front-end readiness. So even if the transport supports V6, we do have to look for V4 services. So service provider starts to look at the dual step scenario, but it does not help in long term because V4 is anyway exhausting. We started to look at CGNAT, which again is a short term pertaining to it being stateful and the login overhead with it. So we started to look at pure V6 transport, and that's map methods, translation and encapsulation. With that, we had a few operational considerations to look at, as in what to choose as in translation or encapsulation. Coming up to that, the first one is HTTP redirection. So for our FTTH services, we had to do the redirection at the entry point of the IP network, whereas if the packet was encapsulated, we will have to do it over the edge of the network. So we thought MAPT was a better solution than using the E version of it. And then the encapsulation method would hide the L4 header, and it would be operationally challenging for us to do the per subscriber policies therein. So we started to look at and do the lab trials with MAPT for per subscriber policies.
Excuse me, could I just ask a clarification question, Ian Farrer? I've got a reasonable amount of experience of building software solutions based on encapsulation, and I'm not sure I quite understand the problem that you're describing there. It's not something that I've seen, so could you expand a bit more on what exactly you're seeing there?
You mean for the HTTP?
With the problem you saw.
Yeah, so in the redirection, we started to use literal instead of using the DNS name in the packet, so it didn't really help us when we were using the encapsulation method.
Right, and I suppose the question is, I don't really understand, or I haven't seen the architecture that you've got there, but at what point are your gateways? Do you have largely 4 domains and then centralized gateways, or are you doing the translation within the home gateway?
To be frank, we are very early stage of deciding the methodology, so we're not yet that far to see.
So you tried different ones, and okay, yeah.
Yeah, sure. Thank you. Then the third consideration we had was the DP enablement in the network, which we needed for our customized services for our customers and the tiered services. We do have to do some analysis on the readiness and intelligence for the DPI devices when we use MAP in the network. So if I want to summarize the consideration and the challenges we see, from the content perspective, there are still too many V4 only hosts in the network. The home gateway or CP is not yet V6 ready, or I would say low trust home gateway is still not in production. The third one, which is fading away, is MAPT was not in standard yet when we had started looking at it, but I see it's in the final stage of getting an RFC number, so it should be easy for us to enforce vendor to support us in as many ways as possible. Yeah, I think with that I end my presentation. Thank you.
Okay, thank you. So questions, comments, further discussion?
Hello, Matthews. Just, do you have a reference or something where if we were interested in getting more information about your approach?
I can speak with you in person and share the approach details, sure.
Okay, seeing none. Thank you.
Thank you. Thanks, Fred. Thank you.
Okay, Akira?
Good afternoon, everybody. My name is Akira Nakagawa of JPNE. Probably most of you don't know about JPNE. JPNE is one of the Japanese, a kind of ISP. Japanese situation is a little bit different from other countries, so it is not exactly ISP, but basically the idea is ISP. And today I'll show you, I'll share information about Japanese IPv6 deployment status, and then I'll tell you about IPv6 deployment in JPNE. And after that, I'll talk about MAPE in the second one. And finally, I'll share information about some experience of our company. Firstly, I'll talk about Japanese IPv6 status. And this is the IPv6 history in Japan. Since about 2000 or 2001, Japanese leading company started IPv6, but it was not deployed so much. And then in 2011, NTT East-West, east sides of Japan and West Japan, two NTT companies started IPv6. That's the start of the business in Japan. And NTT East-West enable IPv6 on access network. NTT East and West doesn't have backbone network, internet connectivity. So, and in Japan, there are many ISPs that doesn't have access network. So many ISPs can start IPv6 service using NTT East-West access network. And at the same time, ISPs with access network also started IPv6. This is one of the measurement that is published on the net. It is observed by Akamai. In Japanese IPv6 deployment rate is about 5.5%. This is a Japanese situation. And this is a slide. Probably most of you know this page. And according to this page, Japanese company or network, I listed some networks, Japanese networks. Number 3 is KDDI, and then CTC, SoftBank BB, and STNet. STNet is a subsidiary of one of the power companies in Japan, and ITSCOM. This is cable TV, cable. This is the ranking of Japanese company. And this is the structure of Japanese network provider. I divided into four groups. And as I told you, NTT East-West has access network, and it doesn't have internet connectivity. And there are many ISPs those use NTT East-West access network. And this is one of the groups. And then there are some companies that have access network, KDDI, CTC, and some companies. And third group is cables. Cable is, there are many cable operators in Japan, in each region. It is different from, for example, comparing to United States. For example, in United States, Comcast is very big, and not many cable operators. But in Japan, there are many operators in Japan. And finally, there are some 5 or 6 companies, subsidiaries of power companies. And the share of FTTH is here. The NTT East-West has a big share in Japan. And I'll show you the V6 rate of NTT East-West and KDDI CTC in next page. This is the IPv6 rate of NGN or NTT East-West. NGN is a network name of next generation network of NTT East-West. The number of the IPv6 users is increasing. Now 800. It's the end of last year, so today the end of the March, it's about 1,000 users. And V6 rate is 5.3%. Today, the end of March, I think, I guess it's more than 6 and less than 7, probably. This is a V6 rate. And this is the V6 rate of KDDI and CTC. Second group. And KDDI completed IPv6. KDDI completed FTTH network. And CTC is increasing. Today it's probably 70%.
So when you say 99% of KDDI's customers have IPv6 deployed, that's from KDDI's perspective?
Yes.
So the question of whether they use it is another question.
Whether?
Is it? Is that a true statement?
True.
The question is, when they have dual stack, both IPv4 and IPv6, does that mean they always choose IPv6, or do some of them still only use IPv4?
All.
So every subscriber
yes.
actually has
automatically
a CPE and a host.
KDDI delivers CPE to customers, all customers.
So your company's CPEs are V6 capable?
My company is not KDDI.
Well, you're a subsidiary of, but
so,
okay. Yeah. So, okay.
My company, JPNE, is different. I'll tell you later. Okay.
Answer to that question is they do use it. The statistics are in, you can find that by looking at, I think Akamai publishes per ASN statistics, and the numbers, and the number of world IPv6 launch actually is about 20 or 25%. 19, okay, and you need to factor out that they are also a huge mobile provider with tens of millions of users which do not have V6, and so you do the math.
Yes. And it is a, I will answer the question from Fred in this slide. And this is the V6 transition status in Japan. Now, some providers started IPv4 over V6. And dual stack, many types of dual stack. Firstly, KDDI is pure or normal dual stack, as I explained you. And JPNE, where I'm working for, and JPNE started MAP-E since 2 years ago, or 1 year and 11 months ago. And Multifeed started DS Lite, and BBX started I think 1 year ago, V6 and V4 tunnel. And OCN, Sonnet, and some companies, ISPs, is V4, V6 on PPPoE. And JPIX is 464 extract. There are a variety of transition type in Japan. And I forgot to tell you that these companies, these operators use NTT East-West access network. They don't have access network. And JPA IX 464 extract doesn't 464X doesn't limit the access network. You can use any network. And this is the recent outstanding progress in Japan. Many CP vendors, makers, started to announced or started to sell IPv6 or V4 over V6 capable home gateway. NTT East West started about 2 years ago, MAPI, and Yamaha, DS Lite, IIJ, Cisco, Huawei, Buffalo, and the multi-feed started DS Lite the October 2014. So in Japan, we can use these home gateways, home routers. And recently, Buffalo started to sell MAPI and DS Lite. Buffalo is Japanese CP company. And this is during Apricot 2 weeks ago, 3 weeks ago. And NEC platforms released MAPI 464X and DS Lite. This is the Japanese very new activity. And it was the Japanese V6 deployment status. And there I'll change my topic and I'll talk about MAP-E. Battery is dying. So. You can see a lot similar type of this slide on the internet. So, but I'll show you again. And there are MAP-E is tunnel and stateless network. And stateless network is we chose stateless network because stateless network has no logging and no session management, and it scales easy. But we cannot do the DPI translation. And this is the
back up one slide, if you would. Question for you. Yeah. At the bottom, you state that translation enables traffic engineering without DPI. For a tunnel, the implication is you have to use DPI to do traffic engineering?
Yes, it is.
Okay.
Yes, it's true.
Okay, that I think is an important data point. Okay, continue. Thank you.
This is the MAP-E. I'll explain you briefly. MAP-E is a tunnel model, and tunnel is between BR, center node, and home router. And it has address sharing function at BR, center node. And stateless, it means no CGN. The NAT is on the home router, as like traditional home IPv4, traditional one. This is the summary of the MAP-E. And it is the entire MAP-E network in our company. I'll explain the two lines in the center. And on the right side, we can do the local communications, both IPv6 and IPv4 over V6. So the packet doesn't have to go up to the center node for local communication. And the DNS transport is IPv6. It's simple because it doesn't have to bypass the detour the center node. It's the MAP-E in our network. This is the reason we chose MAP-E. Firstly, it's easy to operate. No logging and no session management, and center node scales very easily. The second one is easy customer support. So customers don't have to configure by themselves. And thirdly, avoiding traffic from center node. I explained the previous page. Directly, customers' communication is directly connected. Yes.
Ian Farrar, can I just ask a question about how you're provisioning your clients? What protocol are you using for provisioning CPEs? CPE provisioning, which protocol do you use?
CPE protocol?
Yeah, so you've got the tunnel endpoints in the home gateway.
Hmm?
And how are you provisioning the mapping rules?
Provisioning? The home router, if you connect the home router to the line, the home router asks the server in our company and get the configuration from the server.
So what mechanism do you use? What protocol is that?
It is not disclosed, so sorry.
Magic then, okay.
And why MAPI for users? It's like air, so it's same as previous traditional IPv4 and V6. Yes.
Yeah, Michael Abrams. So if we go back to the last slide, have you had any complaints about users not being able to use, something that is not UDP and TCP? Because I guess that doesn't work.
No, we haven't.
No complaints?
No complaints. But for enterprise customers, there are some restrictions. For example, if there are some applications that choose the port number, this one is address sharing system, so it's difficult to it's difficult to communicate from outside to inside.
Yeah, okay. Yeah, just my question is that I have a VPN connection that uses PPTP or whatever it is in Windows, and it sends GRE packets and doesn't work through these kind of mechanisms. Just was wondering if you had any problems with that. Yes, I know why it doesn't work, but it's like, as a customer, it works on my other connection that I have at home. So as soon as I'm behind these kind of mechanisms, it doesn't work. So if I were a customer and an ISP providing me this service, I would be kind of, why doesn't it work? That was my question, if they hadn't received any complaints.
Hi, Suprita Reliance. I wanted to know, so if you're using MapE, how do you, and no login you're using, then how do you identify subscribers for, as in, if later in the, if you need to identify a subscriber who used that session, how do you do that without logging it?
Session?
Session, if you're not logging the session.
Loading?
So how do you identify the subscriber? As in,
So the question is, how do you identify your subscribers?
Yeah.
Okay.
Identify?
So in our country, we have this requirement that we should be able to identify the subscriber for a period of at least 1 month, and the logs should be retained.
Is that the subscriber using a given IPv4 address?
Yeah.
Okay.
So
Yeah, so Mike, please, Lorenzo.
I think the answer is that the mapping is deterministic. So at any point in time, 20 years in the future or 20 years in the past, if you have the port on the other side, like at the server, and you have the IP address, then you know what customer that was.
Thank you.
Lorenzo Colidi, if I become your customer, can I use ping?
Yes, you can. In outbound.
All right. Well,
So the question is, can you use protocols that don't have a port number?
No, because like a GRE doesn't really work anyway, like PPTP doesn't really work anyway, so, but ping is kind of important to me.
Okay. Well, you can send all the pings you want.
Will I get any reply?
Yes, you will.
Philip Matthews, are you using this only for residential customers, or are you also going to do this for business customers?
Both, but main customer is residential one.
Residential, okay. And just being there, do you have some way of allowing a customer to sort of opt out, or you know, do you have a way of saying, okay, I'm not going to put this customer behind this for, you know, because they want to do ping or whatever? Or is it like all customers get this?
All customer? Not all customers.
So you have sort of two classes of customers, ones that get it, and then you have a way of taking some of those that, you know, have complained to you or whatever, and to take them out.
But we haven't have complaints from our customers. So we recommend this MAPI to our customers.
Okay, so for now, all customers that you have applied this to, they stay there.
Yes.
Okay, just for the ping, actually the ID can mapping, so you can outbound ping things. And for Cernet implementation, actually, you can also ping inbound. We have a ping beacon server, so you can use that to test. Because that's something local server for a group of users, not specific for us.
Okay.
This is our final goal. Our final goal is V4 sunset. Now we are in the second stage. First stage was overlaying IPv4 V6. And then now we are offloading IPv4 traffic to IPv6. But it takes a long time, maybe. And then finally, we will remove overlapped IPv4. And I'll show you some experience of our company. This is not talking about MAPI, but it is just a speed test. This is the temporal event network in Tokyo, one of the hotels in Tokyo, like the picture on the above. And we use this line, we use this service as a customer, and not any tuning. And it's completely normal environment. And we put PC below the home router, and I use the two speed test site above. And this is the speed, the result of the speed test. The average is about 800 mega. 670 is, there is 600, but basically about 800 mega, or around 800 mega. This is just a result of the test. And MAPI is stateless, and we have to fix the port number before designing the this service. I cannot show you the number of the port, but we designed enough ports per customers. We tried over-subscribing test before designing it. And now it's enough port.
Ole Tran, do you use on your home router, do you use address dependent or address independent NAT?
Both. It is difficult in Japanese situation, but we can use independent.
When you said both, I'm a little confused. When you say both, do you do it so that on a per application basis, so you identify the applications that you can handle address dependence and use dependence for those, or is it just some implementations do one and some implementations do the other?
Sorry?
Can you explain what you do with address dependence and address independence and how you see different port usage?
Port usage? Port usage is, I don't understand dependent or independent in this case, but we assign fixed number of port.
Right, but so against, so Behave strongly recommends address independence, and that's what I hope Dan Wing isn't in the room because I don't use these terms correctly, but I was used to be the cone type NAT. So you essentially used one port and you allowed incoming connections from anywhere, right? But dependence, then you only accept incoming from the outbound connection you have. So you create a 5-tuple binding essentially in the NAT. But that allows you to overload the ports a lot. So if you had 16 ports, you could still have millions of connections, assuming
5 tuples. 5 tuples.
Yes.
Yes.
Okay.
Two questions, I think. How many ports do you give?
Sorry.
So you don't tell your users how many ports you give?
No.
Do you tell them that they don't have an IP address?
They are...
No, so there are other ISPs that provide V6. Do you tell them that you don't provide like IPv4, or do you not tell them?
We tell them both.
You tell them that you provide both V4 and V6? Okay.
Yes. Our ISPs tell in Japanese local situation.
And they say that they only have some ports?
I don't know exactly what they are saying, but we don't tell anybody about the number of the port, so they don't tell the customers any port.
I guess I need to subscribe or publish that then.
Well, in Akira's defense, if I was to try to explain what an address is to my wife or my daughter, they would get lost very quickly. Ports? Yeah. So I'm not sure the average subscriber in the world would understand the question. So, Akira.
Okay. Go ahead. And it's a simple troubleshooting tool. Customers don't have to use this, but customer can use this. From PC, there are 3 points for testing. Test 1 is before internet IP reachability, and test 2 is IP reachability with name resolution, and test 3, 4, and test 5, 6. And I'll show you the image of the computer. This is a test screen of the computer. Sorry, it's in Japanese. And if you start, click the center button, the test starts. And it automatically starts test 1, test 2, test 3, and test 7. And you can see, okay, and it's easy to find where the failure point is. It's the troubleshooting tool. And this is the big issue for us, for I think everybody who use address sharing system. I think we have to do 2 points. One is taking log of port number at server and or firewall load balancer in order to find the sender. And second one is offloading traffic to IPv6 is very important because it will increase the possibility of finding the sender. So all of us, I think all of us have to do both of these. This is a traffic growth. I want to show from this graph that MAPI user is increasing. And most of the traffic is Google. I don't have to explain anymore this.
So anything worth saying is said by Google. Okay. Okay.
Eric Klein, I was going to ask this question later on. Notoriously, in the past, Japanese content providers don't have quad A's on their websites. So are you working with Nico Nico Doga or anybody to try to get more Japanese sites to have quad A's so that it's not just Google and Facebook?
Nico Nico Doga?
Yeah. Are you going to work with
No,
Japanese content providers?
not yet, but I hope.
Someday. All right.
To answer my own question, V6 プラス一部サービスを利用できない場合があります which means
So we do English
there is
and
some part of services it is possible that do not work on V6 Plus. This is one of what one of their customers says, including a big globe phone, fixed IP services, something involving like fixed port numbers, etc., etc. So they do go out and say this stuff. Anyway, if this stuff is not going to work for you, they do say, like if games, stuff that uses specific ports and so on. Oh, and then you can't use SMTP because we block it. So they go out and say that.
But even though our system is MAPI, but if you use address sharing system, there are some applications that cannot be used. It's same as other sharing system.
So, Ole Trond again, I just wanted to second that point. I think that's important that any type of address sharing you choose, then you will get that. This isn't a property of MAPI. What is a property of MAPI, though, just to have my map hat on, is that it does support full addresses. So for customers who do need those services, you could push them over to a map domain that supported full IPv4 addresses if you wanted. So map can do support, normal plain V4 service. The legacy stuff you did in the 70s.
Okay. This is the IPv6 rate over network. Now, the V6 rate is about 20%. It's gradually increasing. The left one is May of last year. So it's about 10 months, 5% increase, increasing 5% during this 10 months. And this is the summary of this presentation. Firstly, Japanese V6 users and traffic are increasing. And second one, Japanese network providers have introduced variety of V6 transition technology. And MAP is stable, easy operation, and easy customer support. Speed is fast enough. But fourth one is important to take logging of port at server, load balancer, firewall. And finally, one important thing is to offload traffic to V6. Thank you.
Great, thank you. So that last point could be summarized as if you intend to transition, transitioning helps?
Yeah.
Okay. So, great. So any other questions or comments for Akira? Okay, thank you. Xing-Lei? Yeah, and I must inform you to stand in the box that's kind of sort of pink down there.
Thank you. So I'm Cindy, and I will discuss the deployment of MAP-T. So, okay, this is okay. So, actually, currently we have 3 drafts in the editor line, all standard. So the MapD draft, MapE draft, and the MapDHCP draft. And our implementation actually have all these 3 compiled. I mean, follow those standard. And you can see actually the only difference between MapT and MapE is the data path, either translation RFC 6145 or encapsulation RFC 2473. So, and for actually there are 2 cases. One case is CERNET. I'm working for China Education Research Network. Actually, we have 2 backbones. One is called CERNET, which is IPv4. And another is called CERNET2. It is IPv6 only backbone. And the CERNET, we have 20 years operation, and the CERNET2 is about 10 years operation. And so originally the users for CERNET2 is IPv6 only. And later actually we deploy the translator between CERNET and CERNET2. So the IPv6 only host can communicate with the IPv4 internet, and also IPv6 only servers can be accessed by the IPv4 client in the global internet. However, the problem is for applications embedded IPv4 literals and for IPv4 only applications. In that case, we introduce double translation. So that's the origin of the MapT ideas. And then actually, currently we use a little bit modified version of the MapT in CERNET. The reason is CERNET, they connected to campus network, so each individual host, you cannot put a home gateway for that. So instead, we put a translator in the border of the campus network rather than individual subnet. So that's the thing. So you can see for BMR, actually, for each CPE, they got a set of IPv4 addresses or subnet, not a fractional IPv4 because that's aggregated. So that's the first difference. And the second, because it's campus network. And so actually we are not use DHCPv6 to assign or configure the CPE in this case. And the third one, probably it's more interesting, is actually we combined MapT and MapE together. Okay, so that's the next slide. Yeah.
Ian Farrow.
Yeah.
Can I just ask a quick clarification question? So if you've got a V4 prefix allocated, how many users, V4 users, have you got behind that prefix?
Okay, that's in the next slide.
Well,
Yeah.
so the observation on this is you've still got a smaller scale NAT gateway at that point with a number of users behind it. So do you not then need to have some element of logging at that gateway in order to have traceability for those users?
What?
So the way I see, or I understand what
Yeah.
you're describing here, is that you have a gateway device between the V4 domain and
Yeah.
the map domain.
Mhm.
You're allocating a pool of V4 addresses,
Mhm.
and there is a centralized NAT function, which is the border between the V4 and the V6 domain. So as you've got more than one user behind that, do you now need to, do you reintroduce a CGN or a NAT logging requirement at that point?
Oh, okay, that's a stateless CGN, so that's some kind of variation. Yeah.
Okay, I'll pick up with you.
Oh, okay. Maybe I explain later.
It's a deployment model I haven't
Yeah.
considered, so I'll be
Okay.
interested to understand it further.
Okay, that's the trick we are playing. The default is MapT, so it's translation mode. And in the corner case, for example, if with IPv4 options or like fragmentation case, DF1 and MF equals 1, or those kind of VPN cases, then actually we switch to MapE. So that's the tricks. And actually, we have an individual draft. It is originally in the software working group. If you want to know the details, you can take a look of this draft. So that's the thing. It's quite easy. If you see IPv4OPS, then actually you switch to encapsulation. And for the other side, because you can just check of the next headers. If next header is IPv4, then it's translation. If it's whatever thing. So you can see that. Okay, this is the port thing. We did some tests for this. So you can see the first day, the ratio is 256, and the second day is 512. So it's going on. And the number of concurrent port you can have. For example, in the day 6, actually we have 8K people or hosts sharing a single IPv4 address, and the concurrent port actually is only 7. And the left figure is TCP, and the right is UDP. So that's the thing you can see. And the details or the colors is the top percentage of the port consume this thing. So that's different color. And you can see our conclusion is if the sharing ratio is less than 500, so it's quite safe. Very few exceed this kind of ratio. However, if greater than 512K, actually probably some heavy user will have impact of the experience. So that's basically the ratio we choose. And also you can see different shape of the TCP and the UDP. And for TCP, actually, it's mainly the web user, HTTP traffic. And the UDP, it's DS. So if the standard DS actually can use IPv6 to do that. However, a lot of users or students try to use like a Google 8.8.8.8 to bypass the Great Firewall. So that's why a lot of UDP traffics. So that's basically thing. So that's the experience. And currently for example, this is Tsinghua University. We deployed that for about 1 year. And we have multiple SSIDs for wireless networks. And we have 2 cases for different SSID. You can see like on both, the subscribers is about 800. So in total, it's like 1K users and quite stable. So that's the case. And actually, for this one, actually, that's the ratio is 1K. So 1,000 users share a single IPv4 address. So that's the case. Another case, China Telecom. And we have joined projects with China Telecom. So that's the deployment. And in China Telecom case, actually, we are using DHCP V6, exactly the definition of the draft I mentioned earlier. And we use ISC, DHCP server software, and extend that. And the BRAS is doing the DHCP V6 proxy, so not modified by the BRAS, just by passing the information. And for CP, actually, we are using D-Link. It's about $16, so very cheap OpenWRT things. And in this case, actually, each CPE got a fraction of IPv4 address. And in this case, China Telecom want to use 128 ratios. So it's quite safe. And I mentioned the DHCP V6. And again, even in this case, we switch between MAP-T and MAP-E. So if the packet contains some things, funny thing or whatever options, then we use MAP-E. In other cases, T can make it lossless, though it's the T because it's easier to fine tune or whatever. to do DPI without decapulation. So the conclusion is quite simple. MAP helps to solve the public IPv4 address depletion problems. And in the case, if you think you can use the ratio of 1,000, then actually we did some calculation. In that case, if the whole China currently about a couple of /8, and the internet population or penetration is only like 40%. If all the users in China to use like map or those kind of things, using the existing IPv4 public address, that's enough. Even the penetration can reach 90%. And the second is, based on experience, translation if you can, encapsulation if you should, so can satisfy both. So any questions?
So, yeah, questions and comments?
Hi, Lee Howard. Have you done any performance measurements to compare how the two protocols perform?
For MAP-T and MAP-E. Okay, actually for TP-Link, OpenWRT, we cannot see difference. If that, we need to make it a big computer to do that. Not yet. Yeah.
Suprita Reliance. I have a question and a comment. Question is, when you were using mixed environment of MAP-T and E, did you need a special support on the CPE device?
Oh yeah, right. That's some kind of like check the incoming packet. If it's contain, for example, IPv4 options, then it do encapsulation rather than translation. And also the BR, you need to check the next header to do the things. That's just a modification of the software, so it's easy.
And it was easy to convince the vendor to implement that?
Well, because it's no draft and no standard, so that's our own code. Yeah, maybe later we can work on that.
Well, it sounds like an experience document.
Yeah, right, that's enough. Don't need to have a standard, because standard is already in T and E drafts. Yeah.
The comment I had was that, coming to the calculation you gave us, even we had that interesting point, like /12 address would give us only 1 million IPv4 addresses. And for a country like India, where there's 1 billion subscribers, even with a sharing ratio of 64, we are only able to support only 64 million subscribers.
Yeah.
So that is a point of concern for us also. Thank you.
Yeah.
Matt Mathis, it sounded like you made an assumption that the primary UDP traffic was DNS. There are a number of protocols getting a lot of attention at this IETF that are potentially heavy-duty data transfers over UDP, user data transport protocols over UDP. Did you have any experience with them?
Yeah, actually, current experience, UDP, I mean, DNS is the most UDP users, but also we try, for example, we are doing videos, so DVTS traffic or those kind of things, that's no problem. So
it's no problem?
No
okay.
problems.
Just want to make sure.
Back. Come on up to the forward mic.
Yeah, Mukam Taman, you did mention that you do checks on a per packet basis to decide whether to switch from MAP T to E. Would you have some data about the scalability of that? Because when I think research in universities, I think there's potentially a large number of people. Do you have some data that you can share about how scalable that has been? The performance impact.
Okay, actually it's less than 1% of the packet switch to encapsulation. That's the statistics we have. So very tiny.
But that check is being done on every single packet that comes in.
Yeah, right.
So
that's quite easy because we are doing translation. So every field in the IP packet need to be checked.
Okay.
Yeah.
Thank you very much.
So there is no big impact for the performance. Okay, thank you.
Well, yeah, so we have a couple of things we can do. I can move those two short talks forward, or we could have the discussion of IPv4 as a service. What would you prefer?
Just so we're having the conversation in front of everyone, I think we're going to have the IPv4 as a service conversation since we teed it up at the beginning of this. We have some extra time. But I also wanted to ask the working group if having these kinds of conversations, last three presentations weren't presentations of documents, they were field experience reports. Has this been useful for the working group? If so, hum. If meh, hum. Thank you, good. I thought so too.
Yeah, I figured that would be interesting. So what I'm teeing up here, or what I'm coming back to here, Matt, go for it.
I have sort of a side question, but I would expect at some point we reach kind of a cusp where dual stack clients have a better quality of experience than single stack IPv4 because of the prevalence of things like carrier grade NAT. Is anybody aware of anybody who's trying to do that kind of measurement?
Why, yes. I did a panel about a year and a half ago at NetOG with people from Comcast, Cable Labs, and Jeff Houston from APNIC, and all of us showed data showing that we were seeing IPv6 having on average 15% lower latency than IPv4. And is that?
I was more referring to pain suffered by people on IPv4 because of things like carrier grade NAT running out of ports. And so the connectivity, in spite of the performance issues, the connectivity actually might be better on IPv6 if it's available.
IPv6 is a pressure release valve for the pain of carrier grade NAT.
There's a question on the last presentation. So Andrew, your Chinko.
So Xingli, you probably want to find a mic.
Oh, he said never mind.
Oh, okay. So good.
Jeff, we think the back mic doesn't work. So I'm guessing this is in response to the question about, Matt's question about V6 helping offload V4 CGN.
I'm kind of responding to that because your answer, while correct, I don't think answered Matt's question.
No, it didn't.
And the issue about Matt's question is that there is a certain overhead in setting up a binding in a NAT. And certainly if you either got a crappy piece of NAT code that does a linear search or whatever, or the NAT is under heavy pressure, it's that initial SYN packet that gets delayed. The initial SYN packet. So from the user side, not from the server side, you go sort of start to create the connection, mumble around in the NAT, SYN flies out, SYN ACK, and off you go. The kinds of things that we were doing as measurement, or at least I was, and I thought from the others too, we're actually looking at RTT.
Right.
When you look at RTT from the server side, not from the client side, from the server side, you're effectively driving through an established NAT binding. And what you're really looking at is that very marginal overhead of as the packet traverses, it does a lookup on an already established binding, does a translation and moves on, which is milliseconds at worst. It's certainly not an age. The harder problem is to actually try and find the NAT binding time remotely. And the best clue you have is you see a DNS transaction, you start the timer because you're the DNS person, theoretically if you're lucky, and then you look for the first SYN and you do it both in 4 and 6. The problem is there are so many other things happening in the browser or whatever you're doing the testing for, that delay from DNS to first SYN is kind of affected by a whole bunch of stuff, including the temperature outside. And that's why I've never really tried to do that measure systematically. It's just there's so many variables, I'm not sure what I'm going to see.
I'm not sure, I'm going to let everybody else talk too. I'm not sure that it is just the first SYN, since there's still, you have to hold on to the packet while you rewrite the headers, as opposed to just forwarding them, which the SYN would be the big one. And you don't know that the CGN path is the same as everything else's path.
Maybe I just buy crappy NATs at home. But in the crappy NATs that I buy at home, that first SYN takes an age. The rest is kind of okay.
Yeah, maybe I'll be.
On security, I'm kind of skeptical about that actually. I don't. So any NAT that's able to operate in steady state has at least in throughput terms, such low latency that you wouldn't be able to measure it at all. Google do have a lot of data about IPv6 performance to our servers, and what we see is anything that happens here is completely dwarfed by, peering latencies, CGN placement that's not in line, that sort of thing. Those are things that really influence latency. Another thing is that the failure modes are very different, right? I think I would personally expect the CGN to work very, very well until it just started dropping sessions because the users run out of ports. And that's you see that not in latency but in reliability. And finally, you have, some websites might do load balancing wrong. I mean, we are not innocent of that. If you're in certain places of the world, you'll see that V6 is substantially worse than V4, and it is very hard to make an argument to change that for as long as V6 is only 5% of your traffic. It's an ongoing issue. So I think connectivity on V6 is going to be better at best, but on average it might be similar or possibly even worse depending on what you do.
Matt?
I'm actually still worried about a different failure case, which everybody seems to have missed, and that is, it's very easy for us, being Google, having more than 64,000 connections to a single IP address from a VIF, which is carrying services on a single IP address. And this means we blow out the port space in the NAT, and we don't know it necessarily happens. The symptom that I see that I've occasionally been suspicious of is I'm sitting typically in a hotel room, and random objects don't load from Google, but everything else seems to be okay. And I hit the page reload, and a different subset of things don't load, and everything seems to be okay. Now, this was in the time before we were doing single connections all the time, but I still see really, really strange behavior specifically to Google that doesn't often apply to other people. And I look, and I can often tell if there's a carrier grade NAT or something of large scale going on there, and it's like, gee, I wonder how many users I'm sharing this address with. And I don't have any way of seeing that.
Okay, so now let's go to this mic over here. And does that mic actually work? No, come on over to this mic.
Sorry, should we wait or? Okay, David Lampard. Just to give an answer to the SYN delay question, it's quite simply caused by hardware vendors putting the NAT in hardware. So the first packet punts to the CPU, and that's where the delay is coming from. And it does indeed mean that it's a crappy NAT because you didn't pay enough money to get the CPU only treatment of NAT. So. Milliseconds? No, I do think it's going to go up to milliseconds. I know.
Okay, use the mic.
Milliseconds would mean like hundreds of sessions in steady state. Yeah. Then it falls over like as soon as you look at it.
The interface between the hardware engine and the CPU is pretty slow at times, like old buses and stuff like that, if you're a crappy vendor.
Yes, but the NAT is advertised as being able to do X million sessions per second, new sessions per second, which means that the throughput is at least, one every X millionth of a second.
The hardware implementations have ratings like 100 sessions per second, not like millions. No, this is not CGN. This is like end customer devices.
Hi, Bob Vajpayee, Jakob Senior Street Bremen. So just because people were asking on what kind of performance measurements people have done. So just to complement on Jess Houston's study, we actually measure TCP connect times from the client side using dual stack probes deployed behind residential networks. And we have been doing this for more than a year, and what we see is TCP connect times to dual stack websites have improved over time, but they are still worse compared to V4. And on a separate note, when we measure YouTube performance, we see that YouTube performance is actually lower in V6 than over V4, primarily because there are no content caches available or largely missing content caches over V6 networks. Thanks.
Joel Yeagley with the former Zynga hat on. I'm pretty sure my port overload NAT can overload your port overload NAT. That's definitely happened, and it has the sorts of results that people have described. So if you make, 500,000 new API calls to, I don't know, some site like Facebook per second, you can find that out, and we do certainly see that in data center environments with sort of legacy, very high-scale CGNAT devices. That's fun. It's fun, especially when you caused it, because then you get to fix it on your side first.
To answer Matt's earlier question about how you see V4 port exhaustion, I think what you do is you measure dual stack users at a sufficiently high run rate that when the port binding, and you force every measurement to go to a new host name and just open a new connection. And you assume that when a port binding fails, you observe that in the form of V4 failing and V6 succeeding. And you basically look at that in the failure rate. Or you factor it into the latency distribution, and that you see that there's a spike at the SYN retransmission time, which is higher than the spike in V6. So you can actually do this using A to B measurements. Because there's always a spike at, in latency delta at the SYN retransmission times of popular operating systems in case the first SYN gets lost. But by looking at the difference in the height of that spike, you could potentially find out how many sessions were failing through the CGN.
Ian Farrer. Can I just ask for the list that you've got down there, can we add lightweight 406 onto there? It's going along with standard strikes with the rest of them, and we've got a couple of years.
4/6, did you say?
Lightweight 4/6.
LW 406.
Oh, okay.
Great, so we should move on to the question we asked.
Yeah, if we must.
What do you think?
We only have one working mic out there, so people that want to talk can come to this mic.
Mohamed Boukhaya from Telecom. Just to remove this slide, because there is already one RFC that describes the deployment and guidelines for the slide.
Sorry, I didn't understand.
There's already a DS Lite deployment guidelines doc.
Yeah, there is already an RFC for that.
So, okay.
Good, work's done, check.
Alonso Cleary, I think it's an awesome idea if the people who write that operational guidance have deployments that are not test deployments, but production. So that's 464xlat, yes. SIITDC, yes. MapE, yes, probably. MapT, yes. But you have to pick and choose your authors. DS Lite, yes. But they're not in this room, are they? Huh?
That was the last comment, is there already is the deployment guideline there.
There's an RFC for DS Lite. I'm not interested in RFCs. This is guidance to deployments. Who's that written by? Was it written by someone who has a deployment? Who? How many users?
This is exactly the same, the question we have when we wrote the mobile profile. We receive this kind of question. This is not, I don't think that this is, we deploy this slide. The people who are co-author on that RFC are people who deploy their slides. So we know the problems that are encountered for that context, and the main issues for the DSLite context are already captured in that RFC. What I am saying here is that I don't think that we need to add another document unless there is some additional issues that people that are deploying this lab elsewhere in the world find are not captured in that existing RFC.
We don't know until we ask them.
Yeah.
So for using the power of Google, I've discovered that you're talking about RFC 6908.
Exactly.
That's pretty much it. I don't know Lightwork 406 until it's... I would like to not see any documents about these providing implementation guidance until it actually becomes real. And by real, I mean like out in production with, yeah. How many users? More than 100,000. All right.
Suresh Krishnan. So I just had a small question. So if it says guidance, like are you also going to provide guidance about selection or no among these things? Because that's going to become something very controversial and hard to agree upon. So
Well, I don't think we can say pick one. I mean, just in the discussion that we've had in the last hour, we haven't picked one. And people have given their reasons for whatever they picked. I think what people can document is what their experience was and what their the things that they thought about in the course of making a choice.
okay. So there is already some work in software that we can decide to just bring over here. There's like people who started writing some map deployment stuff, and we also have something for MapT already as well. So if like the areas decide like this is the best place to do it, we can ship the documents over. There's already some documents that have been worked on.
Eric Green, Cisco. So I think we should do this way. But I would love to have the same structure for each and every guide. So once, for instance, having all the same topics, talking each and every guide, such thing like user accountability, logging, security, for instance, or whatever. Having the same structure, that would be important.
So tell you what, to that end, Eric, I'm going to send an email to the list, and I invite everyone to reply, and let's discuss what we want covered in that document. Okay. The mic seems to be draining, and we're actually 12 minutes before the top of the hour. So I would suggest that we're done today, and we'll pick up tomorrow.
Blue sheets?
Yeah, I have one. Where's the other blue sheet? So I thought that was a very productive session. Yeah.
How much coaching did you provide them?
Hmm?
How much coaching did you provide them?
So I actually spent a fair amount of time listening. Yeah, so no problem.
together soon.